Welcome everyone to this live. Our lives are shorter form webinars where we go over technical code-focused content. And as always, we have some community notes and shout-outs to make. There are some upcoming community events, like the one that Jack in chat just mentioned. We are often at Airflow meetups, and this time the lineup is a very international one. There's one on the 9th in Paris, one on the 20th, that's a tentative date, so this might still change, in Bangalore, and there's a London Airflow meetup. That one, I know that three astronomer people at least are planning to attend. So if you are in the area or close, drop by and talk to people who use Airflow in person. As always, you can join our Slack if you have any questions. And we have a content highlight, a very special one this time. You may have noticed Airflow 2.6 is out. And maybe you already are anxiously awaiting hearing Kenton walk you through the new features. And we are going to do that in a week on the 9th of May. So if you want to register for that webinar, it's on the same page. I will drop the links to all of the events and the webinar and also the blog post in chat in a second. And in terms of blog posts, the one that I wanted to call out today is made by Ryan. He wrote a blog post about some new Airflow 2.6 features that help you prevent getting tasks stuck in queue. Very, very exciting read. Can highly recommend it. And as every time, there's an Airflow Summit coming up in Toronto in September. So register if you haven't, and if you want to meet with all kinds of Airflow people in person. All right, and I'm going to drop all of these links in chat in a second, but I want to hand it over. Let's see if I can find the right button of Zoom. Yep. Daniel, take it away and tell us more about the Astro SDK.
Absolutely. And thank you guys all. Thank you all for showing up. Definitely very excited to talk about this. This is a project that's been very close to my heart for quite a while now. And so this is a talk on Airflow DAGs made easy, introducing the Astro SDK. Quick thing about myself. My name is Daniel. I'm a PMC in the Airflow project. My first major contribution was the Kubernetes executor, and I've been working at Astronomer for about 4.5 years now, really trying to figure out what the next version of Airflow looks like. And so about 1.5 years, 2 years ago, we were given kind of the task of hey, rewrite Airflow DAG writing, because we're kind of getting a lot of feedback where, for someone who hasn't used Airflow before, there's a pretty heavy startup cost. So for example, you have to know a lot of kind of custom Airflow things, like how to use Jinja templates, how to use the bit shift operator to connect tasks, how to find your operators, what custom operators to use. And we wanted to build something that felt a lot more native, kind of you can develop Python, you can develop naturally, and then you end up with an Airflow DAG without having to think about it. And that's where the Astro Python SDK comes from. So basically, the Astro Python SDK allows you to write self-documenting, database-agnostic Python code. And we really saw that, when it comes to data engineering, the two big things people really care about are SQL, Python, and basically extracting and loading. So once you get your data into a SQL or Python environment, you can kind of use those common languages to do the processing, but then getting it there is also a pretty important step. Kind of keyed up in a single sentence, the Astro SDK is a package built on top of OSS Airflow to allow you to focus on Python code and pipelines, not on Airflow. And that is an important part of this. This is built on top of Apache Airflow. So this library does not require any Astronomer bits. It doesn't require you to be an Astronomer customer. You pip install it on top of your Airflow and it works. Oops. So let's take a common use case of ELT. And so when it comes to ELT, you're loading the data from Snowflake, you're filtering it, you're joining it with a feature table, and then you have to probably have some sort of a reporting table at the end of your processing. And normally you have to create a temporary table for every step along the way here. And you have to manage each of those temporary tables. And we kind of asked ourselves, what would it look like to have a kind of more high-level Python DSL where you load, you transform, and you merge, and you don't have to think about those deeper functionalities. And so we kind of came up with this common use case of, extract, filter, analyze, join, and load. This is just a common use case for a lot of ELT, ETL pipelines. And so the use case we discussed is, I'm a data scientist on a marketing team who wants to perform a sentiment analysis of Reddit posts about Airflow. I need to get data from the Reddit API, put it in Snowflake, clean it, pass it through our inference model, and then merge the result of the sentiment analysis to some common reporting table where it can be shown on a dashboard. So let's talk about extraction. When you're doing this with traditional Airflow operators, you kind of have to hope that someone's already created that operator for you. So in this case, if you're loading from S3 to Snowflake, you have to hope that there is an existing S3 to Snowflake operator, but also it doesn't create a table for you. So you have to run your own create table statement ahead of time, knowing what the actual shape of the table is, and then use the bit shift operator to set dependency. But that dependency is very dumb. It doesn't know anything. There's no richness in that information, which is very unfortunate because when data is moving, that's when it's most valuable. So instead, we created this aql.load file function. And what's nice about this is all you have to tell us is, where's the data coming from? Where's it going to? And we handle everything else. So in this case, this is what it would look like to load from an S3 bucket with an S3 connection ID to an arbitrary temporary Snowflake table. So there are two main kind of objects that are common within the Astro SDK, files and tables. Files point to either a local or a remote file. We have a lot of remote object stores. We have HTTP, and we support a lot of common formats like CSV, NGJSON, Parquet, and others, depending on what the needs you have for the data. And then table is just a kind of a pointer to a table in a data warehouse. So what schema, what database, what connection ID, those are all things that are in the table object. And through doing that, we allow you to basically be able to pass tables around between tasks because you have this abstraction layer. Notable is that you can give the table a name and then we'll store it as an actual table, or you don't give it a name and we store it as a temporary table. And we've done high scale testing with this data, and we found very equivalent, like for a lot of very common use cases like GCS to BigQuery and Snowflake, S3 to Snowflake, we've found very similar levels of speed when it comes to how long it takes to load data versus when you're doing it through the native tools like BQLoad or Snowflake Copy. But we also have this ability to do ELT through a Pandas data frame. So you might be talking about an API where you want to do something a little bit more fancy. You want to cleanse the data as it's coming in before you put it into your database. So looking at the Reddit example. So Reddit has this API praw, and it's not so easy as just send an HTTP request and you get the data. You kind of want to do some cleansing first. So let's say I am a data engineer with a team of data scientists, and I want to give them a function where they just give me a date time and I will run the query with the correct filters for them. You're able to just, without any knowledge of how to create an Airflow operator, you just create this function, you add aql.dataframe, and as long as you return a pandas data frame, that can actually be returned as a data frame or as a table. And so now you've basically created an Airflow operator from scratch in 5 minutes of pandas, instead of having to go through, see how to extend base operator, how to write an execute function. So even someone with very minimal Airflow knowledge can now create their own Airflow connectors, which is very valuable for the common scenario of one data engineer supporting a team of data scientists. You can also, of course, take advantage of Airflow's hooks. So Salesforce ingestion is a very common use case. So you can actually use the Salesforce hook to make a query based on the parameters given and then return that as a data frame so it passes into the Astro SDK ecosystem. One thing to also note is you can actually export the files as well. So in this case, maybe I find the Airflow posts, I cleanse them, and then I want to put them back in S3 in a different bucket so that others can use it. Well, you just pass in the data frame, you pass in the output file, and we handle everything else for you, and it's stored in whatever format you want, where you want it stored. Also worth noting is that you can actually pass in an output table argument to a data frame function, and then we will pass the output data frame into that SQL table. So in this case, maybe we're doing a data frame function, but we already know we want to pass it into Snowflake or BigQuery. Well, you just give us a table object, and we automatically handle the conversion of data frame to SQL table. Now let's talk a little bit about the transformation part of the ELT pipeline. So when using traditional Airflow operators, we have Snowflake operators, we have BigQuery operators, but each of those is a very different operator maintained by different people, and they have different arguments. So there's no real kind of, if you wanted to switch your DAGs from BigQuery to Snowflake, for example, or Databricks to Snowflake, you would have to kind of rewrite a lot of things. And you also have to, if you want to use temporary tables, you have to add your own create or replace table, and you have to manage the names of those temp tables. And it kind of makes the ELT feel a lot more clunky and low level. You don't really get the feeling of your data moving between tasks. So to handle that, we actually have this function called AQL.transform. And what AQL.transform allows you to do is not only can you just give us select statements and we'll handle the table creation, but you can also use functional composition to say, hey, take the output of this SQL function, pass it into this SQL function. And so you can actually create a chain that becomes an Airflow DAG of SQL queries that allows you to run complex transformations in pieces rather than all at once. When doing AQL.transform, you can pass in multiple tables. So if you're doing a join, you can pass in as many tables as you want, and we will handle all of that in our Jinja templating. And you could pass an output table if you know specifically where you want to pass the output of that new temporary or non-temporary table as this output table argument. So you can, like, here's a good example of, like, you can even pass just like the functions themselves, and basically this is generating a multi-stage DAG in what is essentially amounts to like 3 lines of code. Oh, and of course, not all SQL functions can fit inside of your Airflow DAG. You might have a SQL function that's 100, 150 lines, and to handle that, you're going to really want to use an AQL.transform file where you can actually point it at a SQL file, give us the parameters, and we will run that SQL file as if it was an AQL.transform. So you're not limited to just what can fit in your Python DAG. You can use regular SQL, add in the templating at the end, and now you have a templatable DAG. When it comes to analysis, this is kind of where a lot of this shines, in that you can really pass in SQL tables into Pandas and then Pandas back into SQL, and we handle all of that immediately. So in this case, combined data was an AQL.transform file. We pass it into this data frame to run against the model. We will automatically convert that table into a data frame. And then by passing this output table, we can pass that back into Snowflake to then be merged into the reporting table. So we really wanted to kind of give this feeling of SQL as a first-class citizen within Airflow. And then finally, at least for this case, we have a merge function. And so, merge is interesting in the SQL world, where every single database has a very different way of doing merges. You'll see that they all have pretty different nomenclature. And so if you're trying to test out a DAG against both Postgres and BigQuery and Snowflake, you basically have to write 3 completely different queries and hope that they all work the same. So to handle that, we actually have an AQL.merge function. And so for a lot of the common merge cases, you can just use this function, pass in the merge columns, targets, and the keys, and we'll do all of the merging for you. And really, it's only if you're doing something very special that you will have to actually just use a merge function instead. Now, we talked a lot about generating temporary tables as a way of passing SQL between tasks in an Airflow DAG. But what would happen if we ran this 100 times, or we're running this 10 times a day? Well, essentially what would happen is lots of garbage. You're going to have a lot of temporary tables filling up your Snowflake instance. You're going to get a very angry call from your DBA asking why your Airflow is just creating a bunch of nasty name tables. And so to address this, we created this AQL.cleanup function. And what's nice about the cleanup function is it actually runs in parallel to the rest of the DAG, and it just continually waits for the DAG to complete before going through, finding all temporary tables, and then deleting them one by one. So with AQL.cleanup, you have this assurance that once the DAG finishes running, we will go back in and we'll clean up all the temporary tables that have been created by that specific DAG run. And of course, probably one of the biggest things that really excites me about this is how testable it is. Testing in Airflow DAGs, testing in workflow orchestration in general has always been kind of a iffy question. People like past test data. There's not really a great story around it. And as of Airflow 2.5, we have this new function called dag.test, which makes testing a lot easier because now you can actually pass in connection files, variable files that override your connections and variables. So you can now run the DAG as a single process on that machine with those test connections to see what happens. And what's especially cool is that dag.test makes IDE support possible. So in your environment variables, when you're running or debugging, just add this one environment variable to allow Astro to basically be serialized between tasks. And you can actually put in breakpoints in your Python functions. And because these are decorated Python functions, these will basically act as regular Python, act as regular Python. So you can actually see as your DAG is running against whatever test data you're pointing it at, you can see what your data looks like. And one cool kind of thing about that is that we even use that for unit and integration testing. So if you look at the Astro SDK, GitHub, one thing you'll notice is that we actually use the Astro SDK to test the Astro SDK. So in this case, we have a validate function where we're testing, let's say we're testing this SQL query. We create a sample DAG using PyTest. We run that SQL query, and then we pass the result of that SQL query into this validate function. And so we can actually run assertions against our data at test time. So it's really easy to just load whatever data into your test database or test connection, run whatever query you want to test, and then add this Python validate function at the end. And so we've had a lot of luck with integration and unit testing using that. And one last thing to mention is that the Astro SDK works against a pretty wide variety of databases, file types, and file stores. We're running a little low on time, so I'm not going to go through all of them, but it is notable that we do pretty much all the major data warehouses and all the common data file stores. And we really make it easy to mix and match. You can pass your Snowflake tables into Pandas, or you can pass your Delta Lake tables into Snowflake pretty simply using what we've built here. The big takeaway messages is Astro SDK opens up Airflow to a whole new class of data scientists and data engineers. I've actually been using the Astro SDK for writing DAGs. I've found it to be so much easier. I've used Airflow for years. And what's nice is I don't have to think in terms of connectors. I don't have to think in terms of operators. I just write Python, I test it locally, and now I have a running DAG within a half hour. When I went to Chicago earlier this week, and I wrote a fully running DAG on the plane without Wi-Fi because I didn't have to look up operators, which was nice. It helps you think in terms of DAGs instead of data pipelines. And the biggest thing is that it's very production ready. We're at 1.5.3. We've been testing this for a while. There's one Astronomer customer that's been running 100,000 tasks per week using the Astro SDK. And so we've been seeing this used in production, and we've had generally very positive feedback. But we are extremely responsive. So I invite you to try it, give us feedback, let us know if you have any feature requests or bug requests, and people will get back to you because this is a project we care about a lot. A huge thank you to the team that helped build this. And of course, please check out the GitHub Astronomer Astro SDK GitHub, or Astro Python SDK on PyPy. All right, thank you so much.
Thank you so much, Daniel. That was great. I hadn't seen the validate function yet. So again, I learned something new. There were two questions actually that came in and I wanted to keep for you. The first one is in the Q&A feature. Jack is asking, I'm just going to read it out loud. I am relegated to using MWAA for our initial use cases. I will advocate for moving over to Astronomer in the future, but I already had to convince folks to switch from step functions to Airflow. Is this SDK OSS or part of Astronomer?
The Astro SDK is an Apache 2.0 open source library. It's owned by Astronomer. It's in our GitHub repo, but it'll work just fine on MWAA or GCC. This is not meant to just be for Astronomer customers. This is meant to give all Airflow users a new, better way of writing DAGs.
Yeah, thank you. And also, if you are successful in your advocation, there are people at Astronomer who can help you migrate from other systems like MWAA to Astronomer. So you don't have to worry about doing work now that might be lost later. Yeah, but great advocating for Airflow. And the second question in the chat is, can you elaborate on why it's better for cleanup tasks for the cleanup task to run in parallel rather than being dependent on the final ELT task?
So there are two things that we were thinking about there. So firstly, you actually can pass in a list of tasks to the cleanup if you want the cleanup to depend on a specific group of tasks. The reason why it was nice to have it run in parallel is it kind of allows us to keep the DAG very clean, because otherwise, if you had it dependent on other tasks, you'd kind of see just all these lines going to this one single task, and it would be kind of ugly. And then as far as having it dependent on the last task, we really wanted to kind of make sure it was dependent on all the tasks. Otherwise, you run a situation where maybe you just want that last task to be cleaned up and you don't want the temp table cleaned up elsewhere. So we offer basically two modes, either parallel mode or you pick the upstreams mode.
Thank you. That was a great answer. Thanks from Avi too. If you have one more question, that's your last chance to put it in the chat. I put 2 links in the chat just now. We made a small little example repository that has one DAG that uses the Astro SDK, uses a couple of its operators. And the other one is a link to get a free try at our Airflow exam to get Airflow certified. So if there are no more questions, I think that was all. Yeah, thank you so much, Daniel, for the great walkthrough.
Awesome. Thank you all so much for joining.
Yeah, have a nice day, everyone.